and we're dealing with some algebra, and in this instance, we're dealing with an ellipse. So an ellipse is just a set of points in a plane. The sum of whose distances from two fixed points is constant. Each fixed point is called a focus. The graph of an ellipse is not a function. It's not a function because it doesn't pass a vertical line test, right? Foci, that's the plural of focus. The foci, as well as the vertices, and as this textbook calls the major endpoints, they are located on the major axis. The vertices and the foci are along the major axis, and then the other axis is the minor axis. Now, just some background about an ellipse. An ellipse is the shape for the orbit of most of the planets. We talked about a parabola, and the parabola has a satellite dish kind of functionality or whatever. So this is what makes an ellipse an ellipse. In this little definition, it says the set of all points whose sum from two fixed distance is constant. So here's what that means. In this ellipse, you have two focus points, which are called foci, the plural. If you were to take, let's say, this focus point, and then you have a point on a line, if you were to measure that distance with a ruler, you would get some distance. If we were to take the distance to that point from our other focus point and we were to measure that, we would get some distance, right? If you add those two distances, you get a number of major, you get a distance. That distance is the same no matter where your points are on the ellipse. So for example, if I were to have a point here on my ellipse, if I were to measure from the point on my ellipse to this focus, if I were to measure the point on the ellipse to the other focus, add those two things together, I'm going to get that same exact number as with the red lines. All right, so that's what makes an ellipse an ellipse. All right. All right, so here are the equations for an ellipse. So keep in mind, here again, we're dealing with two sets of formulas. These are the formulas for ellipses centered at the origin. So notice if you have what is called a horizontal major axis, your ellipse takes this model form. Okay? And we're going to elaborate on this. If your ellipse has a vertical axis, it takes this model form. All right. Now, I included a blank sheet of paper in the notes. So what we're going to do is we're just going to sketch out the formulas for the equation at the center. All right. So if you notice, these are the formulas for the equation at the center. However, if you look further down on the notes, I believe it's the next to the last page, you do see these formulas. And these are the formulas for ellipses that are not at the center. So sort of like what we did last time, we're going to look at the most basic formulas for conics at the center, and then we're going to move up to the more advanced formulas. All right, so on that little blank sheet that's included, we're going to just sketch out the ellipses. So here we have ellipses. Okay, once it moves. All right. Okay, these are for ellipses centered at the origin. So we're going to look at this instead of looking at like four formulas, we're looking at two formulas. So the first set we're looking at are ellipses that have a horizontal major axis. So if the ellipse has a horizontal major axis, this is the model form: x squared over a squared plus y squared over b squared is equal to 1. And this is standard form. All right, so now we're going to look at two aspects: horizontal major axis and vertical major axis. For both of these setups, A has to be greater than B. And also for both of these setups, C is equal to the square root of A squared minus B squared. Right? So those apply to both of these set of formulas. Right? So if you have a horizontal major axis, the graph is going to look something like this. It's going to be oblong about the x-axis. So notice that the major axis is longer than the minor axis. All right, so notice that this horizontal length is longer than this vertical. So if this is what your graph looks like, this is your model form, and if this is your model form, this is what your graph looks like. Notice that if you're looking at the denominators, the biggest number is underneath the x variable, and then your graph looks like this. So then along this major axis, we have the vertices. I'm just going to call that B and B prime. So it's centered at the origin, right? But the vertices are on either side of the ellipse. So the vertices, which they call the major axis points, are found plus or minus a comma 0. So it's like if I'm given my model form, I basically will take the square root of that denominator, and that would give me a, and then I can substitute a into the formula. Next, we have our minor axis points. So our minor axis points are located along the y-axis. I'm just going to call 1b and 1b prime. They have the coordinate 0, comma, plus or minus b. And then along our major axis, we have our foci points. I'm going to call this F and this F prime. They have the coordinates plus or minus C, comma, 0. So you can find C by using this formula. C is going to equal to the square root of a squared plus b squared. All right. So this is the most basic formula for an ellipse with a horizontal major axis. Now we're going to look at an ellipse with a vertical major axis. Right, so if it has a vertical major axis, your model form is x squared over b squared. So notice now that the smallest number is underneath that x squared variable, plus y squared over a squared equals the 1. So notice they look the same, but if you have a vertical major axis, notice that the largest number is now underneath your y variable. So here's what the rough sketch of a graph will look like. So in this ellipse, our vertical axis is going to be longer than the horizontal axis. So it should look something like that. So remember, along the major axis, you can find the vertices. So the major axis points here are 0 plus or minus a. The minor axis points, I'm just going to label those B and B prime in the drawing. Those have the coordinates plus or minus B comma 0. And the foci, they're going to be located along the major axis. I'm just going to call one F and one F prime. And the foci have the coordinates 0 plus or minus C. So those are basically just the coordinates for these points. Any questions about the formula? So for each one of these formulas, A has to be greater than B. So if you're given an equation, you're looking for the biggest denominator. And once you find the biggest denominator, you locate the variable that it's underneath, and then that kind of determines the model forms. Right. So notice for the other set of formulas right here, just to kind of put these up on the screen. All right, so notice here, the x and the y variables, notice they have constants attached. All right, so these are not at the center. All right, so now that we've kind of taken a look at the formulas, let's graph one. We're going to graph one by hand, and I'm going to actually pull up X, Y, Z homework and see how it's graphed. All right, so when we graph, the first thing we need to do is plot the center. So notice that for my center, this is centered at the origin, right? Because I don't have any constants attached to the X or Y variable. So this is centered at the origin, 0, comma 0. Right, so I'm just going to plot that point, 0, comma 0. The next thing you want to do is you want to determine the model form. And what I mean by that is you want to determine if this thing has a horizontal or vertical axis. So in order to determine the axis, I'm just going to look for the largest denominator. So the largest denominator is 25. 25 is underneath the x variable. So this thing is going to have a horizontal major axis. Right. So once you've determined the major axis, then you want to kind of move along that major axis. So this thing has a major axis, a horizontal So then I can actually use one of my model forms. So if I have a horizontal major axis, notice that the coordinates for the major axis, and I'm just going to cut and paste this really quick. All right. So notice if I have a horizontal major axis, so I just kind of copied and pasted this from above. If I were to write this in standard form, this would be written as x squared over 5 squared. So when you write it in standard form, they actually want to see this denominator squared. Plus y squared over 2 squared is equal to 1. This is standard form. So it's in standard form. So notice that A is going to be 5, right? And B is going to be 4. So if I take a look at my formulas down here, the major axis or the vertices, they're going to be located at -5, 0 and 5, 0, right? So I can plot those. So I'm at the origin, I'm going to plot -5, 0. So I'm going to go -5 places to the right. Since the y coordinate is 0, I'm going to stay on that point. I'm going to plot 5, 0. So from the origin, I'm going to move 5 places to the right. My y coordinate is 0. I'm going to stay on that point. Now I just want to plot the minor axis. So it's 0, plus or minus b. So from my model form, a is 5 and b is equal to 2, right? So that means the minor axis points are 0, -2 and 0, +2. So to plot 0, -2, I'm at the origin. Since x is 0, I don't move to the left. I don't move to the right. I'm going to stay on the y-axis. Since y is -2, I'm going to go down 2. And to plot 0, 2, I'm going to stay on the y-axis and go up 2. And if you're doing it by hand, this is the graph. Kind of drunk, but it's supposed to be in this. As far as XYZ homework is concerned, I should have that problem up. Let me just bring it up. Because it's a little bit different in using XYZ homework. Okay, 1, 2. All right, so I believe this was number. I thought I had them where I could. Okay, here it is. X squared, over 25 plus y squared over 4 to the 1. So first thing is you want to choose the right graph. So this would be an ellipse. So it doesn't show you both orientations. This just kind of shows an ellipse with the horizontal axis. I want to plot my center. So my center is 0, 0. Since we know that this thing has a horizontal axis, I want to go like 5 units to the left or to the right. Doesn't really matter. So I'm going to go like 5 to the right. So that's the same thing as like plotting 5, 0. And then once you go up or down 2, notice that it kind of makes the ellipse. So that's why you see these like 2 weird points down here on the graph. So let me just kind of go through that again. First thing you do is plot the center. So we know that this is a center, no constants attached to X or Y. Since this has a horizontal major axis, so notice in standard form, this would be 5 squared, right? So I can either go like -5 or I can go to +5. So let's say if I go here, since the y coordinate is 2, right? The square root of 4 is 2, I'm going to go up 2. And it should give you the graph. Is everybody okay with that? All right. All right, so that was the graph. So we did it by hand, not so hard by hand, and then kind of even easier with the computer. All right, now here is one where we're given the model form, but we have to pull out the equation in standard form, and we want to pull out the axis points and the foci. All right, so first off, we're going to put this in standard form. So standard form means that your equation has to be set equal to 1, and your denominators must be written in a squared format. All right. So to write this in standard form, it's simply going to be x squared divided by 3 squared plus y squared divided by 2 squared is equal to 1. So unfortunately, you have to put that into this equation part. Once we have the standard form, so let me just write some steps. First thing to do is put it in standard form. The second thing you should do is find A, B, C, H, and K. So what is A? Well, remember from our model form, it's x squared over a squared. So A is actually 3. Is everybody okay with A being 3? B is going to be what? 2. And I'm pulling that from the denominators. What is C? Well, we can find C. Remember, there's a formula for C. C is equal to the square root of a squared minus b squared. So C is equal to the square root of a squared minus b squared. A squared is equal to 9. B squared is equal to 4. So C is equal to the square root of 9 minus 4. So C is equal to the square root of 5. Right. And since this thing is centered at the origin, H and K are going to be what? 0. Is everybody okay with what I did? I just put it in standard form. I was able to pull out A and B, so be careful about the model form. A and B, We found C, and then H and K are 0. So the third thing we're going to do is choose a model form. So when I say model form, does this have a horizontal or a vertical major axis? Well, in order to determine, look at your denominators. The largest denominator is underneath the x variable. So therefore, looking back at our model forms, this thing has a horizontal major axis. So what I'm going to do is simply take those formulas, choose a model form, and substitute. Okay, so I want to paste. All right, so I chose a model form which was horizontal. Let me just jot that in. And then I'm just going to substitute in A, B, and C. So for the major axis points, they have the coordinates plus or minus a comma 0. So a is going to be 3. So my major axis points are negative 3 comma 0 and 3 comma 0. The minor axis points have the coordinates 0 comma plus or minus b. And we found that b was 2. So we have 0 comma negative 2 and 0 comma positive 2. And then the value for C was square root of 5. So our foci are negative square root of 5 comma 0 and positive square root of 5 comma 0. So we're mainly using these 3 steps. Put it in standard form, find A, B, C, H, and K, choose a model form, and then substitute. So those are examples of ellipses centered at the origin. All right. Now we're going to take a look at ellipses that are not at the origin. All right. So here's one to graph. So we're going to graph it by hand. All right. Pretty much the same way we graphed the other one. And then we're going to take a look at the computer. So it says graph the equation x plus 1 quantity square over 1 plus y minus 3 quantity square over 16 equal to 1. So just as we did before, the first thing is we're going to plot the center. So what is the center? So remember, the center has the coordinates h comma k. H follows x and k follows y. And remember, the signs are going to change. So if h follows x, h is going to be negative 1. K follows y, and it has a sign change, so k is going to be 3. So that's my center, negative 1 comma 3. And that's what I'm going to plot. So I'm at the origin. I'm going to go one place to the left, and I'm going to go up 3. Okay, now there's a formula way to do this, and there's also like a less advanced way to do it. So we're going to kind of do it the less advanced way and stay away from the formulas just to save time. But notice I plotted the center. Notice that if you look at the model forms, the largest number is underneath the y variable. So this thing is going to have a vertical major axis. So if we put this in standard form, it's x plus 1 quantity squared over 1 squared plus y minus 3 quantity squared over 4 squared. So from the center, I'm going to move along my y-axis. So since A is 4, from the center, I'm going to go up 4, 1, 2, 3, 4. From the center, I'm going to go down 4, 1, 2, 3, 4. And then as far as B is concerned, from my center, I'm going to go 1 unit to the left and 1 unit to the right. And this is the ellipse. So everybody see what I did? I just plotted the center. After you plot the center, you always move along the major axis. So I went up 4, then I went down 4, and then for the major axis, I went over 1 and to the left. So sort of the same thing you would have did at the center, except the center's kind of straight away from the origin. All right, now here's what it looks like on the, I believe this is it, x plus 1. Yeah. Okay, so same thing. All right, you want to choose the correct conic, so it's ellipse. I noticed they don't really give you all that orientation stuff. First thing I'm going to do is plot the center. So we determined that the center was -1, +3. Keep in mind that the center is straight away from the origin. Since this has a vertical major axis, I'm going to go down 4, 1, 2, 3, 4, 1 place to the right, and then that should be the graph. So graph's not too hard. Just plot the center and move along the major axis first. All right. All right, so now let's take a look at finding the standard form, the axis points, and the foci of an that is not in the center. All right. So notice I kind of included the formulas on these. All right, so the first thing is, let's put it in standard form. So remember, standard form means that your equation has to equal to 1. The denominator should be written out as squares. And another thing I'm really not mentioning, both of these terms, because on this left-hand side you have 2 terms. Both of these terms are positive. So in standard form, I believe this is going to look like x minus 1 quantity squared over 4 squared plus y plus 1 quantity squared over 3 squared is equal to 1. All right, so that is standard form. So just like we did before, once we put it in standard form, then we found I should have written that down here. So once we put it in standard form, the second thing we did was we found A, B, C, H, and K. So what does A equal to? Well, if we go back to our standard form, we're looking for the largest denominator, so that's that 4, well, 4. So A is going to equal to 4. B, in this case, is going to equal to 3. So remember, these are from the model form, so B is going to equal to 3. What is C? Well, we can find C. C is equal to the square root of A squared minus B squared. A squared is equal to 16. B squared is equal to 9. So that's the square root of 16 minus 9. So C is equal to the square root of 7. So notice for A squared, I'm using 16. Right? And then for B squared, I'm using 9. All right. So what is H? So if we go back to our center, so remember that H follows X. So H is going to be positive 1. K follows Y. Remember there's a sign change. So we have negative 1. So our center is positive 1, negative 1. All right, so H is positive 1, and K is going to equal to negative. All right, so is everybody okay with where these values come from? So now we need to choose one of the model forms, and then we're going to substitute. So the third step is to choose a model form and substitute. All right, so what is a model form? Does this thing have a horizontal major axis or a vertical major axis? Well, first we're going to look at the largest denominator. The largest denominator is underneath the x variable, so this thing has a horizontal major axis. All right. So I am going to copy that little piece. So I'm just going to copy this. Okay, this is to save some writing. All right, so I just kind of copy and pasted that down. So here are the formulas for an ellipse with the horizontal major axis. So I simply want to take these formulas and basically substitute. Let me just kind of put everything on one. And that's it. All right. So we know that the center is positive 1, negative 1. To find the major vertices, We're going to use h plus a comma k comma h minus a comma k. So in that, I'm going to substitute h for 1, k for -1, and a for 4. Well, I'm going to write all of this out. So this would be the major okay, a equal to 4. So here we have h plus a. So that's 1 plus 4 comma k, which is -1. And then we have h minus a. So we have 1 minus 4 comma -1. So we have 5 comma -1 and -3 comma -1. So those would be your major axis points. To find the minor axis points, I'm just using the formula h comma k plus b and h comma k minus b. We're going to substitute h for 1, k for -1, and b for 3. All right, so then this gives us 1 comma -1 plus 3, 1 comma -1 minus 3. So we have 1 comma 2 and 1 comma -4. And those are the minor axis points. And then for the foci, h plus c comma k and h minus c comma k. H is 1, k is -1, and we found c to be the square root of 7. So now I'm just going to substitute. So we have h, which is 1 plus the square root of 7, comma -1, and 1 minus the square root of 7, comma -1. And I believe those would be the foci points. All right, so any question? Once you put it in standard form, find A, B, C, H, and K, choose the right model form, and it's just a matter of substitute. Now, there are a couple of problems at the very end of the homework. There's 2 problems. And this is one of the problems. It says determine whether the given equation represents an ellipse and write it in standard form. Now, here's just the short explanation on this. If you can write it in this form, then it's considered to be an ellipse. All right, if you can put it in this form, either where it has centered at the origin or centered elsewhere. So what we have to do is we have to take this 1, 2, 3, 4, 5 term trinomial. We have to do something called complete the square, and we have to write it in this form. So before we actually do the problem, this is we're gonna kind of look. Well, we're gonna look at completing the square, and this was from. I think if you took math courses here, this was probably math 102 because I don't think it was in college algebra. But all right, so here's what it means to complete the square. And to complete the square is basically one of the methods used to solve a quadratic equation. And normally when it's not used in any context to solve a problem. It's just the mechanics on how you actually do it. So in order to complete the square, and this is kind of abstract at first, and I'm gonna put some numbers in. The first thing you need is you need the proper form. And the proper form is x squared plus bx. All right, so keep in mind, this is one of the methods used to solve a quadratic formula. So now there's a lot of stuff that's implied. The first thing implied is that the coefficient of your squared term has to be a 1. If it's not a 1, you have to force it to be a 1. You also need your first degree term, and notice there's a b in front of this x, which means that you can have a constant other than 1 for your first degree term. So once you have the proper form, the next thing you can do is complete the square. You complete the square by raising half the coefficient of the middle term to the second power. You're really squaring it. So here's what that looks like. You're going to take the coefficient of your middle term. You're going to cut it in half. And then you're going to square it. So you take half of the you don't take the x. We only take the coefficient or the number part of x. We cut it in half and then we square it. That's called complete the square. Once you complete the square, you force a perfect square trinomial, which looks like this: x plus b over 2 quantity squared. So I'm going to put some numbers in this in a second. So here's an example. Complete the square x squared plus 6x. So if you're asked to complete the square, I have the right form, x squared plus 6x. So notice that the coefficient of my first term is 1. I have my second degree term and my first degree term. So I'm going to take half of the coefficient of the middle term and square it. So 6 divided by 3, 6 divided by 2 is 3. So we get x squared plus 6x plus 9, right? So I took half the coefficient in the middle term, so 6 divided by 2 is 3, and then 3 squared is 9. The reason why I put this step here in is because half of the middle number is like the key to writing it to factoring this. So x squared plus 6x plus 9 can actually be written as x plus 3 quantity squared, which is a perfect square trinomial. So that means if you take x plus 3 times itself, you get x squared plus 6x plus 9. So when you complete the square, you force a perfect square trinomial. So that's basically what we're trying to do. All right, so now we're going to take a look at this problem. And let me just move this down. So, all right, so okay, I'm going to get it right soon later. All right, so in order to answer this problem, the first thing we're going to do is we're going to group like variables. So I have 9x squared plus 36x, just kind of putting those together, plus 25y squared minus 50y is equal to 164. So I left all my variables on one side and I just push the constant to the other side. Now I want to complete the square with the x and the y variables. But I run into a problem. For my x variables, I do have the square and the first degree term, but the coefficient for my x square is not a 1, it's a 9. So I'm going to have to force it to be a 1. So the next thing I'm going to do is force a coefficient of 1 for the square terms. So here's basically how I'm going to do that. For my x variables, I'm going to factor out 9. Because if I factor out 9, 9 times what will give us 9x squared? X squared, so I'm kind of forcing that coefficient to be 1. And then 9 times what would give us 36x? Well, if we factor out x, that wouldn't give us the right form to do the complete the square. Okay. All right, so I'm going to do the same thing with the y variable. I'm going to factor out 25. So then I have y squared minus 2y is equal to 164. Does everybody agree with that? We didn't rewrite anything, or we didn't add anything that wasn't already here. So I can go back. 9 times x squared is 9x squared. I started with 9x squared. 9 times 4x is 36x. I started with 36x. 25 times y squared is 25y squared. I started with that. 25 times negative 2y squared is negative 50. And then, I'm sorry. Because I subtracted In its original problem, it was minus 164. So notice for this second step, before that I subtracted that 164. It's originally minus 164. But when I group my like variables, I just want you to notice this. Notice how when that negative 164 is moved to the opposite side, it becomes positive. So now I want to complete the square. And this is where you got to be careful. Plus 4x plus blank plus 25y squared minus 2y plus blank is equal to 164 plus blank plus blank. So I'll explain these blanks in just a second. So now the reason why I put these blanks on the left-hand side, these are because we're going to complete the square. And then the reason why I put the blanks on the right-hand side is because what you add to one side, you got to add the same thing to the other side, right? So as we look at the x variables, I want to complete the square. So if I look at the coefficient of my middle term, it's 4. I want to divide that by 2, and I want to square it. So 4 divided by 2 is 2, and then 2 squared is 4, right? So I'm going to just write in another step. 9 is equal to x squared plus 4x plus 4, right? Because half of 4 is 2, and then 2 squared returns a 4. I want to complete the square with the y variable. So notice that the coefficient for my y variable is negative 2. So I'm going to take negative 2. I'm going to cut that in half, and I'm going to square it. So I get negative 1, and then negative 1 squared is positive 1. So it always throws back a positive. So I'm going to bring that down. Plus 25 times y squared minus 2y plus 1. I'm going to bring down that 164. Now, as far as these blanks are concerned, if I go down here, what did I actually add to the left-hand side? Whatever that is, I need to add the same thing to my right-hand side. So this is where you got to be careful. So notice right here, 9 times x squared, that's 9x squared. I started with that. 9 times 4x is 36x. I started with that. 9 times 4 is 36. I did not start with the 36. I added a 36 to this side when I completed the square. So I must also add a 36 to the other side. So notice that's not just a 4, that's a 36 because we factored out a 9. And then if I check my other variable y, 25 times y squared is 25y squared. We started with that. 25 times negative 2y is negative 50y. We started with negative 50y. 25 times 1 is 25. We did not start with a 25. We added 25 once we completed the square. So since we added 25 to the left-hand side, we must also add 25 to the right hand side. Is everybody okay with that? So now once you add all of that stuff up together, 164 plus 36 plus 25, that should be 225. 164 plus 36 plus 25, 225. So then this becomes 225. But I want you to see where that comes from. So is everybody okay up to this step? So we completed a square. That means these things should be perfect squares. So I'm going to write this as 9 times x plus 2 quantity squared plus 25 times y minus 1 quantity square is equal to 225. Okay, and now we want to put it in, we want to write it in standard form. So I'm going to divide both sides by 225. So now if we reduce that 9 over 25, that reduces down to x plus 2 quantity square over 25 plus y minus 1 quantity square over 9 is equal to 1. And I'm sorry, you got to take this a little bit further. You got to write these denominators out. I just thought about that. This would be 5 squared plus yeah. Make sure you write the denominators out in a squared format.